In this video, I'd like to talk about the math question of the day for January 27th, 2023. And this is a related rates question from calculus. We have two people on bikes that are at the same place. One of the bikers starts riding directly north at a rate of 8 meters per second. 5 seconds after the first biker started riding north, the second starts to ride directly east at a rate of 5 meters per second. At what rate is the distance between the two riders increasing 20 seconds after the second person started riding? Now, like I mentioned, this is a related rates problem from calculus, and these tend to be fairly challenging. And to answer this, you need to have a solid grasp of the basics of calculus, but also a solid understanding of pretty much everything that comes before calculus. Since these types of questions, these word problems, tend to incorporate many different skills from algebra or trigonometry or geometry and combine them into a problem that also requires understanding derivatives or sometimes implicit derivatives or implicit differentiation. So at this point, go ahead and pause the video, see if you can solve this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted this problem, we can start working through it together. And of course, if you have any suggestions for future question of the day videos, please feel free to leave those in the comments. And the main advice for dealing with these types of problems is to try to construct a picture of what's going on. Try to organize everything in here, and then we can start combining that information. So let's just go through it piece by piece. We have that one of the bikers starts riding north at a rate of 8 meters per second. So let's say we have biker 1, they are going due north. This is, we can say biker 1, and their speed, so let's say v1, the velocity of biker 1, this is 8 meters per second, and it's going due north. Now, biker 2, we have here the second starts to ride directly east at a rate of 5 meters per second. So going eastward in this direction, this is biker 2. Let me redo that. And the velocity of biker 2 is 5 meters per second, so they're going a little bit slower. And we also need to make note that this all happens 5 seconds after the first biker starts. So this second biker is getting a delayed start. And then the question is just asking, at what rate is the distance between the two riders increasing 20 seconds after the second person started riding? So we're looking at the distance between the two riders. So this picture here, we don't need to draw it to scale, but we can imagine it looking something like this. So let's consider where each of these bikers are 20 seconds after the second person started riding, which is 25 seconds after the first biker starts going. So we're looking at when the time is 25 seconds after everything begins. And let's say that biker 1 maybe is right here. Again, this doesn't have to be drawn to scale. We're just getting a rough idea. And let's say biker 2 maybe is right here. And we're looking at the distance between the two riders, and we're looking at the rate that this distance is increasing. So if we want the distance between them, we can connect them with a line, and we can do a little bit of calculating here to figure out how far biker 1 and biker 2 have gone. And then using the Pythagorean theorem, since this is a right triangle, we can figure out the current distance between them after 25 seconds. So let's start with biker 1. After 25 seconds, we can just multiply 8 meters per second by 25 to figure out how far biker 1 has gone. And 8 times 25, this is just going to be 200 meters. And for biker 2, remember that this biker starts 5 seconds late, so we really are only going for 20 seconds. and 20 times 5 would be 100. Now, using the Pythagorean theorem, since if we have some right triangle, let's say we have A and B for the legs and C for the hypotenuse, that A squared plus B squared is equal to C squared. And we can figure out what this distance, we can call this D, is actually equal to. And actually, let me use a different letter since we will be taking derivatives. Let's call this Z, and this could be X, and this could be Y. So really, relating these three quantities, we have that X squared plus Y squared is equal to Z squared. But trying to figure out at this exact time what the current distance is, we can figure that out. We have 100 meters squared plus 200 meters squared. This is equal to Z squared. And 100 squared is just 10,000. 200 squared would be 40,000. And if we add those together, we get 50,000. And solving for Z, we just take a square root of each side to find that Z, that distance between the two bikers after 25 seconds, after the first biker started, would be approximately, this is an irrational number since we're taking a square root of a non-perfect square, we get approximately 223.606, or we can just say 61, and the unit would be meters here since we're looking at the distance apart. Now, to figure out the rate that this distance is increasing, that's where we need to use calculus. But we know the relationship between these three sides here in this right triangle since we have the Pythagorean theorem. And all of these distances, x, y, and z, these are all increasing as time increases. But the important thing to remember is that they are all functions of time. We can say that x is really x of t, y is y of t, and of course z is z of t. They all change with time here. So we can take a derivative of everything here with respect to time, or with respect to the variable t. Though we will have to use the chain rule here. We take the derivative of x, or x of t squared. We do the derivative of the outside first. Using the power rule, we bring down the 2 and multiply it by the function, and then we take the derivative of the function itself, the inside here, and the derivative of x, or x of t, we can just write as x prime of t, or maybe just x prime. This is the derivative of this function x with respect to t, or with respect to time, and we do the same thing for y. We bring down the 2, multiply it by the original function, then we take the derivative of the inner function. The derivative of y of t is just y prime of t, or we can write y prime. And for z, we do the same thing, or z squared. We bring down the 2, multiply it by z, and then take the derivative of the inner function, which we can write as z prime. And from here, we can simplify everything, but the main idea is that we want to solve for this z prime here, this rate of change of this distance here with respect to time. And at 25 seconds, we know the x position is 100, the y position is 200, the distance between the two bikers, this z value, would be this number here, 223.61 or so. And we're trying to find z prime, this rate of change of this distance between the two bikers with respect to time. But we also need to know the rate of change of this x position, this biker 2 going towards the east with respect to time. But we know that that's just the velocity of biker 2. So this is also equal to x prime, or the rate of change of this variable x with respect to time. And likewise, this velocity of biker 1, this is really just y prime, since again, we're looking at this y value, this increasing value towards the north, and we're looking at how it changes with respect to time, but we know that's just the velocity here. So we have all of the information. We can solve for z prime, but let's do a little bit of simplification first. So I can scroll down so that we can work on this. Notice everything is divisible by 2, so we can cancel all that, and then we will divide everything by z. So let's actually just divide both sides of the equation by 2z so that we get z prime, which, by the way, we could also write as dz dt, the rate of change of z with respect to time. And the 2's cancel. We get x times by x prime plus y times by y prime, all divided by z. And plugging in our values here, we know that x is at 100 meters, and it's changing with respect to time at 5 meters per second. And we can ignore the units, but if you want to put the units in, you will see that they will cancel out and essentially be equal to meters per second, which is what we would expect there. So we now plug in for y. We have plus y, which is at 200 meters. Again, this is all at 25 seconds after everything started. And the rate of change of y with respect to time is 8. And we divide all of this by the z value, that distance between the two bikers at 25 seconds. And we know that's this number here, this 223.61. And after all of this, we can compute what the rate of change of this distance between the two bikers is with respect to time. So we can plug everything into our calculator. And our final answer would be 9.39148 and so on, but we can just round it here. So this is an approximate value since, again, we took a square root of a non-perfect square, which is irrational. So if we want a decimal, we have to round this. But this would be in the units of meters per second, since that describes this distance changing with respect to time.